Okay, well, good afternoon or good morning, depending on where you are, and thank you for coming to hear about a new tool that we've developed in-house at Janssen to visualize statistical outputs in an automated and dynamic way, and thus facilitate the presentation of safety data by regulatory medical writers. This tool came to fruition through the collaboration of myself, another writer within the Janssen organization, Kendellen, and our statistical programming colleague, Nick Masel. Next slide, please. Historically, regulatory medical writers have performed manual review of statistical outputs summarizing safety data to identify adverse events that are most clinically relevant to discuss. Not only is this process error-prone, but it has become increasingly unwieldy because it is time-intensive. The slowness of the manual method also leaves little time for cross-functional discussion of data and often led to the production of ad hoc outputs on an emergency basis. Next slide, please. To address the challenges just discussed, we created a web-based data visualization tool that supports automated analysis of safety data outputs. We anticipate this tool will support the writing of a range of documents to which safety data are key, especially clinical study reports. This tool allows a writer to quickly and efficiently identify adverse events that are most frequently reported within a study or are differentially reported across treatment groups. This analysis can be iterated over and over at any desired threshold, turning a process that historically took 15 to 20 minutes to complete per output into what seems to us as writers a 30-second miracle. The tool also uses heat mapping to visualize trends. The benefits of this tool are numerous and detailed in the figure, but they all drive into two main areas. First, it allows us as writers to draft content for regulatory documents at a much faster speed. Second, it significantly improves the quality of documents by reducing data errors in preliminary drafts of documents and freeing up the time for cross-functional teams to consider data in a more dynamic and thoughtful way. This also reduces quality control burden and saves our colleagues in programming from last-minute ad hoc requests. Before we present a brief demonstration, Nick will now share the technical details that power the tool.
Thank you, Rich. Okay, so providing a high-level overview of how this was built here to give you some ideas, maybe if you're interested in applying something yourself, or maybe even sparking some interest in R for those who are considering learning R. So the entire application was programmed using R. We used RShiny for our interaction with users. So for the application side, RShiny was used. All of the tables are displayed using an R package called DT, so that's for our data tables. This has a lot of great features right out of the box. So it provides some search functionality, cell coloring to support our heat mapping, and again, all of this is right out of the box. For the front end, we wanted a nice, clean, professional interface, and we used the BS4 Dash package for that. This package has tons of fantastic documentation that makes it very easy to use. So I recommend you checking out their website. And then really the heavy lifter of the group, what's doing all of the data crunching and the processing is dplyr. And specifically, dplyr has a set of variance functions that all end in underscore at. So we'll get into that a little bit more. Next slide. Okay. So what's the main goal, right? So we have RTF documents and we have docx documents that we need to upload into our application. But we have this, and there's all this RTF syntax and docx syntax that isn't really useful for us. So we really need to parse through and get at the data, right? So the first main goal is to just take these files, convert them back to a usable data set containing variables and records. After we've done that, we need to figure out, well, what do we want to process, right? So what variables have counts and percentages in them? Because when it comes down to it, that's what we want to get to, those counts and percentages. Next slide. Okay, so I really want you to hone in on the code on the bottom right. So we have our data, and then we figured out what columns have counts and percentages, and we've stored that in something called counts and percentages. And this is just basically selecting those variables, applying some sort of function to those sets of variables to find the counts for those. And then we want to rename those to something specific that's going to keep those grouped together. So you can think of just prefixing every variable with something, or adding a suffix to every variable with something to let us know that this entire set of variables is now our count variables. Okay, so we've taken our variables that have both counts and percentages. We've now worked through this simple 4-step process here, and now we have a new set of variables that contain all of our counts. So this is really the idea that's just used over and over again, right? So we're taking something, a certain set of variables, applying a certain type of functionality to it to manipulate that, and we're storing those again as a new set of variables with a distinct prefix or suffix so we can get at that set of variables very easily. Okay, so this is one easy, clean way to walk through to now strip out your counts and now have a new set of count variables. We'll go to the next slide. So again, just hone in on the code here. This is another way to do the exact same thing. It's less code. We don't have a select statement. We don't have a rename statement, but it's a little more confusing to look at. So you kind of weigh your balances here. You know, do you want less code or do you want easier to read code? That's a whole nother presentation. But here's another way you can do the same thing with less code. So instead of storing all of your variables, you can on the fly say, give me all the variables that start with CNT underscore. So those are our count variables. Now, what do you want to do to those variables? Let's apply a function to them where we now subtract what the user has supplied as a cutoff. So let's say Megan has said, I want to see everything that has at least 5. So we would now just subtract that out, and now we have a whole new set of variables with EEIS underscore as the suffix. So now we've got our count cutoffs. We have this whole set, and you would just continue on through the rest of your code, just processing set by set of variables with using these two methods. Okay, and with that, I'll pass it to Meg.
What you see on my screen right now is the user interface that we as medical writers see in the tool that Nick has built and was just describing the code for. And this is what it looks like after we've loaded in a statistical output for adverse event data into it. So a user has a couple of different options with how to visualize the data and how to apply different cutoffs to sort of query what's going on in the data set easily. The first kind of grouping of ways that we can visualize the data are to just look at events that exceed incidence in any of our treatment groups. So that's this and this tab. The nice thing to note here is that we can perform these manipulations and querying of the data either by incidence for more common events or at the subject level as well, which is really helpful for us for rare but critical events such as grade 5 or fatal AEs. The other way that you can manipulate and query the data are to actually use the exceeding differential columns here and here, and those allow us to automatically define thresholds where we want to query where different treatment groups are differing by whatever threshold we like. And this is the one that especially for us seems particularly miraculous because this is something, you know, you used to be able to kind of hunt and peck before and see those most common events in the exceeding incidence tabs. But, you know, the math that this does automatically and quickly for us is really just a massive game changer. So I'll go through so you can actually see how this works for those two buckets of data querying. So here on the exceeding incidence column, really all the user has to do is to enter the incidence cutoff that they want to use. As you can see, that auto-populates to pull just the adverse events that occur in at least a 5% incidence in any of our treatment groups. And as Rich was saying earlier, you know, this really is massive for us as writers, that we can do something like this in just a second or two, rather than that really intensive process of manually searching and then still not being totally sure whether you've caught everything accurately until it goes through the QC process. So that's kind of how it works in terms of telling the program what you would like to see and using those different cutoffs. A couple of additional features that we think are really helpful. One is the color mapping with the intensity of the red color, as you can see. So this is a great way just to quickly visualize For example, if your first column is placebo, and then you're looking at your other groups, you can really start quickly seeing potential safety signals that you might want to discuss with other team members. If you're seeing a lot of items show up as exceeding your incidence in certain groups, and you can really see quickly sort of how your events are partitioning out among your treatment groups. Another really great tool for us is that we're able to toggle between system organ class and preferred term. The default is that it will show everything, but you can very easily switch between those types of AEs to look at it, just across the systems level or a preferred term level very easily, and narrow down what data you're looking at. Another really nice thing that we can use the tool to do is we can use a display column where we can select the treatment groups that are being shown. So let's say if we decide we no longer want to look at one of the groups, whether it be really anything you select, if it's something you no longer want to look at your placebo group, for example, and you just want to look at your different doses as one scenario. You can really focus on the groups that you want to look at directly at any given time. We're also able to sort any of the columns by increasing or decreasing incidence, which is great because often as writers we want to present those adverse events in order. So we're going greatest to least. It does that for us automatically as well. And an additional item that we can kind of interact with the data that the tool is showing us is we have a Boolean search. So you can just search for any individual preferred term or system organ class that you might be interested in. So this is kind of the base case sort of that we're able to query that data, and this allows us to answer questions such as what are the most commonly reported events, which is a really key item that we want to present in regulatory documents, or a number of other questions. Then if we come over to our exceeding differential, so with this, the tool is comparing all of the columns that are how should I say this? So the default for the tool is to compare each of the columns, each of your treatment groups, to the first one. And so just like we did before, we can select whatever incidence cutoff we would like, and to say we only want to see the system organ classes and preferred terms that are at least, by that degree different from our comparator column. So again, this is really great that we can quickly and easily see what's different from our placebo, from our standard of care comparator, or as I'll show you later, within the groups themselves. So similarly to before, we have our heat mapping color now is dual. So the red color are those that are lower in incidence than our comparator group, and those that are in green are higher than our comparator group. And the color intensity is the same as I described before. So this is really great for us because we're able to, again, quickly see, for example, if our investigational treatment group are seeing a lot more or a lot less frequent events very quickly by looking at the colors and looking at the intensity of them. So that's incredibly helpful for us. All the rest of the features in terms of the toggling between system organ class, preferred terms, searches, dropping out columns that we sort of want to remove focus from as we're looking at the data with our teams, all apply here as well. Sort of the new item that allows us to query data in a more complex fashion for this one is you can switch the column or the treatment group to which you're comparing all of the others. So it defaults here to the leftmost column being our kind of baseline comparator, because often in our outputs in-house, that would be our comparator, our placebo, sort of where we want to see a difference from and identify those for a safety signal. But let's say one wanted to no longer look at everything compared to our placebo or standard of care, but we wanted to maybe query some sort of dose response that we may be seeing in our data. So you want to compare to the second column or your lowest dose. We can do that easily as well by just selecting and telling the tool to compare everything to our lowest treatment dose, for example, and then it recalculates everything automatically. So you can start to query questions, sort of, what's different between the groups, or you may have, different background therapies for that you're looking at your investigational product in combination with. So it has an extra bonus. You can really have a lot of flexibility in how you're querying the data. And it's just been incredibly helpful for us as we're navigating ever shorter timelines and wanting to reach ever higher degrees of quality, especially in those early drafts, and to help us have more productive conversations with our teams and do that much faster. So that's sort of what we wanted to share today.